Hello students, today we start the another topic of ionic equilibria is salt hydrolysis. So salt hydrolysis, and in previous lecture we have discussed the number of things. Basically here is the buffer solution and solve the some problem which is based on it. So in today's lecture, it is a salt hydrolysis, means hydrolysis of salt. What is the hydrolysis? Hydrolysis means when there is a salt and water are interact together, what happen? So basically hydrolysis of salt is the reverse process of neutralization reaction. Means in neutralization reaction, there is a formation of salt plus water when neutralization reaction takes place between the acid and base. Simple. Suppose we consider HCl plus NaOH. This is the neutralization reaction. When these are neutralized together, we get the NaCl plus H2O. NaCl plus H2O. So NaCl is the salt. NaCl is the salt. So this is the process, we call it neutralization reaction. It is the neutralization. It is the neutralization. But when the salt and water are react together, it is the hydrolysis. It is the hydrolysis. So the product of neutralization is salt plus water, and the product of the salt hydrolysis is the acid and base. Means when salt are hydrolyzed, they form the acid and base. So due to this, the solution become acidic, more acidic or more basic. That will important. So we are going to discuss this. So the phenomenon of this interaction of cation and anion of salt with H plus and OH minus of the water. The phenomenon means this is the salt. This salt having the cation Na plus and Cl minus. So here is the cation, here is the anion. Okay. So this is the cation of base, it is coming from base, and the anion which is coming from acid. So that's why what is the term? It is the phenomenon of interactions of cation and anion of acid and base with H plus and OH minus. H plus and OH minus of water yielding the acidic and basic solution is the salt hydrolysis. I repeat again. It is the phenomenon of interactions of cation and anion of acid, means, or you simply call cation and anion of salt with H plus and OH minus of water, which yield the acidic and basic solution is the salt hydrolysis. त्याला म्हणतात salt hydrolysis. So NaCl is the salt which has the Na plus and Cl minus is the cation. Water itself has H plus and OH minus. So the H plus, it is a cation of water, and anion of salt are combined together and gives HCl. The cation of salt and anion of water gives NaOH. NaOH is the base and HCl is the acid. HCl is the acid. So this is the reverse reaction, is the salt hydrolysis, and the forward reaction is neutralization reaction. Okay. Next, according to it, there are different types of salts are formed in neutralization reaction depending on the nature of acid and base. So nature of acid and base means we have the four conditions. If acid, so acid is strong as well as weak. Base, again there are two types of base, strong as well as weak. Means using these two things, we get the four combinations. We get the four combination. First, salt of, salt of, first is salt of strong acid and strong base. Strong acid and strong base. We get the four conditions: strong acid, strong base; strong acid, weak base. It is the second condition. Weak acid, strong base; weak acid, weak base. So, first, second, third, and fourth. So we have the four conditions. So we get the four types of salt on four reactions, because nature of acid and nature of base will give which type of salt is formed. So it is a salt of strong acid and strong base. Second, salt of strong acid and weak base. Third, salt of weak acid and strong base. And fourth one is salt of weak acid and weak base. Okay, so we have the four conditions. We're going to discuss one by one. First is salt of strong acid and weak base. KCl, NaCl are the salt of strong acid and strong base. How it? So we write reverse in reverse form. So because we consider this salt, but how we obtain this salt? So this salt, this is obtained on reaction of KOH and HCl, and you know KOH and KOH is a strong base, HCl is a strong acid. So it is a strong acid and strong base. We get this salt. There is a plus is water. Again same thing is here. Here is the NaOH plus HCl. NaOH plus HCl. One more example, NaNO3. NaNO3, sodium nitrate. Again it is obtained from HNO3. मी इकडे बेस लिहितो आधी NaOH HNO3. HNO3 is the acid. So HNO3 is a strong acid, NaOH strong base. Means these are the salt which is obtained on the reaction between strong acid and strong base. Okay? Second one, strong acid, weak base, and the example is NH4Cl. NH4Cl. So NH4Cl, then one more example is CaCl2. CaCl2. Okay, how it? So how NH4Cl is obtained? NH4Cl obtained on reaction between NH3 plus HCl. And HCl is a strong acid, but NH3 is a weak base. तुम्ही म्हणा अमोनिया आणि weak कसा? Weak base काय? तो प्रोटॉन घेतो, त्याचा कॉन्जुगेटेड ऍसिड तयार करतो NH4 प्लस, परत प्रोटॉन लगेच देऊन टाकतो. स्ट्रॉंग कसा राहील? स्ट्रॉंग बेसचा जो कॉन्जुगेटेड ऍसिड असतो तो वीक असला पाहिजे, पण इथं NH4 प्लस इट सेल्फ इज अ स्ट्रॉंग, आणि तो स्ट्रॉंग तयार होतो म्हणून NH4 रिटर्न करून टाकतो, परत NH3 तयार होऊन जातो इमिडिएटली, म्हणून तो वीक आहे. NH3 इज द वीक इन दॅट गिवन रिएक्शन. CaCl2, how it? Calcium hydroxide plus twice HCl. Calcium hydroxide plus twice HCl is the reaction. So CaCl2 also the weak, calcium hydroxide is a weak base, HCl is a strong. Third is salt of weak acid and strong base. Salt of weak acid and strong base. For example, KCN. Another one more example is sodium acetate. These two are salt of coming from weak acid and strong base. आता weak acid म्हणजे काय की जो इझिली प्रोटॉन देणार नाही, आणि स्ट्रॉंग बेस म्हणजे काय तो स्ट्रॉंग असला पाहिजे. आता बघा इथं KOH हा स्ट्रॉंग बेस आहे, पण त्याच्यासोबत HCN हा ऍसिड आहे, कारण की इथं वॉटर तयार होणार ना. इथं OH, याचा OH घ्यायचा, याला H लावायचा. जो सॉल्ट मध्ये कटायन आहे त्याचा, बेस घेताना तिथं OH लावून द्यायचा. बघा इथं K प्लस म्हणजे KOH आणि जो अनायन आहे ऑलरेडी मी तुम्हाला सांगितलंय की कसं कॉम्बिनेशन. तर हा H प्लस दिला, अनायनने H प्लस दिलेला असतो आणि कटायनने OH मायनस दिलेला असतो. म्हणजे रिव्हर्स रिॲक्शन लिहिता आली पाहिजे. इथं बघा हा प्लस आहे म्हणजे याचं काय होईल NaOH आणि उरलेला पार्टला H जोडा ॲसिटिक ॲसिड. Acetic acid and HCN are very weak. They are very less dissociation, less ionization. So these are the weak acids. But KOH and NaOH are strong base. So it is a combination of weak acid and strong base. Last one, weak acid, weak base. An example is NH4CN. NH4CN is the first. Second one example is CH3CONH4. How they are obtained? हे कोणापासून तयार झाले NH4CN, NH3 आणि HCN मधलं. कोणापासून NH3 प्लस HCN. आता NH3 पण वीक बेस आहे आणि HCN पण वीक ॲसिड आहे. हे कोणापासून तयार झालं NH3 प्लस ॲसिटिक ॲसिड. ॲसिटिक ॲसिड पण वीक ॲसिड आहे, NH3 पण weak base है. So both are weak. So these are the combination. So in that topic we mostly going to discuss how these salts are hydrolyzed. How these salts are hydrolyzed with each other and their result is how we're going to discuss some interactions, some interrelations between some parameters. But this is the point here. This is the combination of 4 types and we get the 4 types. We have the 4 types of salts which is obtained and 4 different kind of reactions, 4 different kind of neutralization reaction. Okay, we're going to discuss one by one detail in first case, in second case, in third case, how hydrolysis takes place, what is the mechanism and what is the result of hydrolysis. We're going to discuss one by one. Okay, so going to first combination, first type of salt is, it is a salt of strong acid and strong base. Means hydrolysis of salt of strong acid and strong base. Simple, we consider here KCl. We consider KCl. So basically in aqueous medium, KCl dissociate as a K plus and Cl minus. Okay, K plus and Cl minus. If we add water there, it is aqueous medium. Means water itself there as aqueous medium, but water dissociate as H plus OH minus. So salt and water. So what we expect here, H plus react with, so cation of water react with anion of salt. So these are combined and these are combined. Suppose these two are combined, KCl plus H2O, we get the K plus H plus Cl minus and OH minus. Means what we expect, the H plus and Cl minus combined together we get the KCl and OH plus H plus we get the H2O. Means we back here again these are mixed together, means it is aqueous medium, again it dissociate. Means after this hydrolysis we are not getting the acidic or basic nature. Means what we expect, the result of salt hydrolysis is formation of acidic or basic solution. But here if these two are combined together, what happen, KCl which is obtained on the HCl and all, but here it 100% dissociate or ionized into water in aqueous medium. So further hydrolysis of it and back into acid plus base is not obtained in a given reaction. So ionization or hydrolysis of salt of strong acid and strong base is not possible, means KCl does not undergoes hydrolysis. मग तुम्ही म्हणणार की हा जो KCl आहे हा KOH आणि HClचं कॉम्बिनेशनवरून तयार झालेला आहे, ठीक आहे. आणि त्याचं हे तयार झालं तर मग ह्या दोघांची रिॲक्शन होऊन इथं HCl आणि ह्या दोघांची रिॲक्शन होऊन KOH तयार व्हायला पाहिजे, म्हणजे ॲसिड अँड बेस. हायड्रोलिसिस तर झालंय, पण ऑलरेडी आपल्याला माहिती आहे की KCl ज्यावेळेस ॲक्वियस मिडियम म्हणजेच वॉटर, राईट. तर व्हॉट हॅपन की हे जे तयार होतं यांच्यामध्ये काय होतं की हे आयोनायझेशन झालंय, हे दोघं लगेच रिॲक्ट होणार, हे दोघं लगेच एकमेकांना कंबाईन करणार आणि ते बॅक KCl आणि H2O फॉर्ममध्ये येणार. दॅट मीन्स it back to the HCl or KOH is not possible due to 100% ionization. 100% ionization of the salt. And here it is the strong acid and strong base. Okay, salt of strong acid and strong base. That means these are very weaker conjugated acid and base. They further react with the anion, means with the H plus or H minus is not possible कारण की ते स्ट्रॉंग आहेत. म्हणजे बघा, स्ट्रॉंग ॲसिड आणि बेस एकत्र आल्यानंतर त्यांचे जे कॉन्ज्युगेटेड ॲसिड बेस तयार होतात ते वीक असतात, अपोजिट असतात. मग हा KCl म्हणजेच K प्लस आणि Cl मायनस, K प्लस आणि Cl मायनस हे कॉन्ज्युगेटेड ॲसिड बेस पेअर्स मधले आहेत आणि ते वीक आहेत. वीक असल्यामुळे परत प्रोटॉन ॲक्सेप्ट करणं किंवा परत OH ॲक्सेप्ट करणं डिफिकल्ट आहे कारण ते वीकर आहेत. जर वन ऑफ द पार्ट अनायन और कटायन हा स्ट्रॉंग असेल सॉल्ट मधला तर तो काय करणार, H प्लस किंवा OH मायनस जो असेल, अनायन असेल किंवा कटायन असेल तर तो H प्लस किंवा OH मायनस पिकअप करणार आणि बॅक करणार ॲसिड आणि बेस दोघांपैकी एक कोणीतरी जास्त कॉन्सन्ट्रेशनमध्ये तयार होणार, म्हणजेच त्याचं हायड्रोलिसिस होणार. पण इथं हायड्रोलिसिस होतच नाही का, कारण की हे जे आहेत खूप वीक आहेत. K प्लस परत OH घेणार नाही, Cl परत H प्लस घेणार नाही आणि हे तयारच होणार नाहीत. मग काय होणार, हे सोल्युबल फॉर्ममध्ये राहतील. हे काय असतील, सोल्युबल फॉर्ममध्ये राहतील आणि सोल्युबल फॉर्ममध्ये असल्यामुळे त्यांचं फक्त आयोनायझेशन होईल, हायड्रोलिसिस होणार नाही. सो KCl इज strongly undergoes ionization but not a hydrolysis. It is the first composition we're going to discuss. We're going to second one is here. Okay, we consider the second composition combination, hydrolysis of salt of weak acid and strong base. Weak acid and strong base. Weak acid means acetic acid, strong base means it is a HCl or NaOH. Sorry, strong base means NaOH. So acetic acid and NaOH, these are combined together. So for here we consider acetic acid plus strong base means NaOH, we gives CH3 COONA plus H2O. This is the reaction. So we consider this salt of weak acid and strong base. Okay, let us consider here the hydrolysis of sodium acetate. Sodium acetate. You know, sodium acetate itself is ionized in aqueous condition as a acetate anion and sodium cation. Okay, so when these are ionized together or formation of ions together, when sodium acetate undergoes complete ionization, it forms these two ions. Secondly, the ion, it has tendency, it will react in a small amount of H plus of the water, means it is dissociate first. Water is there, that means it will react with the H plus of the water. So in second case, the anion will react with H plus of the water. So that means here water also ionized, this acetate also, salt also ionized, and here the acid is produced also ionized because it also tendency to ionize itself. So basically in second step what happened, this anion will react with H plus of the acid and we get the acetic acid. We get the acetic acid. So overall, what happened here? This is the salt, means we have the anion of, we have the cation, these two anion and cation, plus this H plus coming from water. So we add water here. We add water here. So this is the hydrolysis. Salt plus water. What happened? So this anion accept the H plus from this water and converts into acetic acid. Okay. Na plus is there. After loss of H plus to the anion, what remain there? OH minus. So what are the products? Acetic acid plus Na plus OH minus. So here water is in excess, so we consider a concentration of water as a constant, we neglect. So only we have this one and this one. Okay, so we first of all neglect or remove the common ions Na plus. So what remaining? At the left side there is anion plus water, and on the other side there is acid plus hydroxide. When we apply law of equilibrium, then it is the KH. K means constant, H means hydrolysis. So it is the hydrolysis constant. Is the hydrolysis constant. Okay, so K is H is the hydrolysis constant. So it is the product acetic acid OH minus upon the concentration of anion, because water is here but we consider the concentration of water as a constant. We consider the concentration of water as a constant. So KH is equal to this one. We get this relation. So if we given the numbering here, this equation first, equation second, here is the equation third, and this one equation number 4. Okay, these are the equations. When acetic acid is produced, acetic acid itself undergoes some ionization, means with KH there is a Ka also present there. Ka also present, as well as Kw also present. Kw means ionization of water, because water itself undergoes ionization. When acetic acid is produced, this acetic acid also will undergoes ionization. So on other side we discussing all. So ionization of weak acid. So acetic acid ionized as a acetate ion and H plus. When here we are applying law of equilibrium again, so we get the K, dissociation constant of acid or ionization constant of acid. It is the product upon reactant. So concentration of acetate ion plus concentration of H plus upon acetic acid. So we get the equation number 5. Here is the equation number 6. Okay. The ionization of pure water also there. Ionization of pure water also there. And ionization of pure water as H plus OH minus. So we get the 7. But you know the concentration of H plus and concentration of OH minus is equal to Kw. Kw is the ionic product of the water. Ionic product of the water. So we have the 8 number equation. So what happened here? We have the Kw, we have the Ka. So first of all, we divide the equation 8 by equation 6. Equation 8 by equation 6. So dividing equation 8 by equation 6, because of here this ionization takes place in water, means here water also ionize, acetic acid also ionize, weak acid also ionize. So we consider both of, and then we divide each other, and the resulting product is we consider here. So here equation 8 means Kw, on the left side there is a Ka is equal to here H plus OH minus upon this one acetic acid concentration, H plus concentration, and this upon acetic acid. So what happened here, we cancel it, the common terms, which are H plus is common term, we remove it. So what remains? Kw upon Ka is equal to, so this side has only acetate anion and OH anion. So concentration of acetate anion and hydroxy anion upon acetic acid, and this is equal to Kh. This is equal to Kh. That means Kh is equal to Kw upon Ka. Kw upon Ka. Because of we already there, what is the equation of acetic acid, and the acetic acid equation, the Kh is already calculated here. The Kh is equal to this ratio. That means Kh is equal to Kw upon Ka. So simply the hydrolysis constant is inversely proportional to the dissociation constant of weak acid. This is the inversely proportional. So this is a relation, means Kh is inversely proportional to the Ka. Kh is inversely proportional to the Ka, means when the more the dissociation constant, less will be the hydrolysis. If less will be the dissociation constant, more will be the hydrolysis. म्हणजेच तुम्हाला बघा आता स्ट्रॉंग ॲसिड अँड बेस याचा Ka जास्त आहे, कारण की डिसोसिएशन कॉन्स्टंट जास्त असेल तर हायड्रोलिसिस कमी होणार. जेवढं स्ट्रॉंग ॲसिड असेल तेवढं याचा हायड्रोलिसिस कमी होणार. सो दीज आर इन्व्हर्सली प्रोपोर्शनल टू दी each other. So this is the relation between hydrolysis constant and dissociation constant of weak acid, which is taking part in the salt formation. So it is all about this one. And now we move to the last point of the today's chapter, is degree of hydrolysis. Okay, degree of hydrolysis we are going to discuss for the above combination, means salt of weak acid and strong base. What is the degree of hydrolysis? So let us consider the same salt, sodium acetate plus water, we get the acid plus base, it is the hydrolysis reaction, and conclusion is salt of weak acid and strong base is readily undergoes hydrolysis because it produces acid plus base. Okay, acid plus base. So we consider at initial stage the acetate ion has concentration, we express denoted as a C is the concentration of acetate ion, or sodium acetate is the salt, and before reaction there is a zero concentration, no formation, there is no acid and base formation at the beginning. That means the concentration is zero. But at equilibrium some salt convert into acid and bases. So acid and bases has concentration, and how much it depends on their degree of hydrolysis, means how many hydrolysis degree, how much hydrolysis is there. It is the H degree of hydrolysis is considered. There is a degree of ionization we consider as alpha, same as here H degree of hydrolysis. So it has concentration into degree of hydrolysis, CH. So what remains here, the concentration of unhydrolyzed salt is, C is the concentration 1 minus H. So 1 mole is supposed to be considered, H is the degree of hydrolysis, that means 1 minus H is the remaining, which is unhydrolyzed salt. So C into 1 minus H, it is unhydrolyzed. So we have this and this two value at the equilibrium point. According to law of equilibrium, Kh is equal to concentration of acid into concentration of base upon concentration of salt. Concentration of salt. The water is there, it is to be considered as a constant. So KH is there, we have the values. So what is the concentration at equilibrium of acetic acid? It is a CH into, what is the concentration of base? Again it is a CH upon, what is the concentration? It is a C1 minus H. And there we consider alpha, C alpha into C alpha, and 1 minus alpha is there. So there is the Ka and Kb, there is a dissociation constant we already discussed. Here is the degree of hydrolysis, again it has same. So H represent the degree of hydrolysis, means how many molecules are hydrolyzed. This is the degree of hydrolysis out of total molecule is the degree of hydrolysis. So what happen here, we get CH square, KH is equal to CH square 1 minus H. So this is the degree of hydrolysis. But suppose the degree of hydrolysis is very small, it is the near very small, that means this value is equal to 1. So this value is equal to 1, that time KH is equal to simply C into H square, C into H square. So using this we get the H is equal to H square is equal to C upon KH, sorry, KH upon C. When we get the value of H square, C comes at the denominator, so H square is equal to KH upon C. So H is equal to, so the square under goes that side as a under root KH upon C. So H is the degree of hydrolysis. H is the degree of hydrolysis, and the relation is H is equal to KH upon C. KH upon C is the relation. So we have the two equations. Okay. So this is the equation number 10. We already have the last equation. It is a KH is equal to KW upon C. So if KH is equal to KW upon C, so this equation 9 and 10 are related with each other, and we get the another equation. So H is equal to under root, what is the KH? KH is equal to KW upon KA upon, this is the C, upon the C. So this equation number 11 is used to calculate degree of hydrolysis. Once we know the concentrations, or we have the value of degree of ionic product of water, if we have the ionization constant of acid, we can easily calculate degree of hydrolysis. So this is all about the today's lecture. In next lecture we discuss another combination which has two remaining. So we stop here.